Hello everyone. Today I am going to discuss about parallel algorithm. What is parallel algorithm? A parallel algorithm is an algorithm that can execute several instructions simultaneously on different processing devices and then combine all the individual output to produce the final result. A parallel algorithm in the design and analysis of an algorithm involves creating algorithms that can execute multiple tasks simultaneously, leveraging the power of parallel computing. This allows for improved performance and scalability, especially in the tasks that can be broken down into the independent parts. They are crucial in modern computing, especially with the rise of multi-core processors and distributed systems. Then analysis of parallel algorithm. Analysis of an algorithm helps us determine whether the algorithm is useful or not. Generally, an algorithm is analyzed based on its execution time, time complexity, and the amount of space complexity it requires. Since we have a sophisticated memory device available at reasonable cost, and storage space is no longer an issue. Hence, space complexity is not given so much for importance. Parallel algorithms are designed to improve the computation speed of a computer. For analyzing a parallel algorithm, we normally consider the following parameters. First of all, time complexity, that means execution time. Then second, total number of processors used. And third, total cost. Then first of all, time complexity. The main reason behind developing parallel algorithm was to reduce the computation time of an algorithm. Thus, evaluating the execution time of an algorithm is extremely important in analyzing its efficiency. Uh, the execution time is measured on the basics of the time taken by an algorithm to solve a problem. The total execution time is calculated from the moment when the algorithm starts execution to the moment it stops. If all the processors do not start or end execution at the same time, then the total execution time of an algorithm is the moment when the first processor are started its execution to the moment when the last processor stop its execution. This is the overall process of working in the time complexity. Then time complexity of an algorithm can be classified into three categories. Uh, First of all, worst case complexity, second, average case complexity, and last, best case complexity. First of all, worst case complexity, it means when the amount of time required by an algorithm for a given input is maximum. This is called worst case complexity. Then second, average case complexity. It means when the amount of time required by an algorithm for a given input is average. It is also known as average case complexity. Then last one, best case complexity. It means when the amount of time required by an algorithm for a given input maximum. This is always known as worst case complexity. Then next, asymptotic analysis. It means the complexity or efficiency of an algorithm is the number of steps executed by the algorithm to get the desired output. Asymptotic analysis is done to calculate the complexity of an algorithm. In its theoretical analysis, in asymptotic analysis, a large length of input is used to calculate the complexity function of the algorithm. Uh, what do you mean by asymptotic? Asymptotic is a condition where a line tends to meet a curve, but they don't intersect. Here, the line and curve is asymptotic to each other. This is known as asymptotic. Asymptotic notation is the easiest way to describe the fastest and slowest possible execution time for an algorithm using high bound and low bound on speed. For this, we use the following notations. First of all, big O notation, second omega notation, and last theta notation. Then big O notations. Big O notations. In mathematics, big O notation is used to respect the asymptotic characteristics of functions. It represents the behavior of a function for large input in a simple and accurate method. It is a method of representing the upper bound and algorithm execution time. It represents the largest amount of the time that an algorithm could take to be complete its execution. The function of f of n is equal to big O of g of n. This is the notation of big O notation. If there exist positive constants c and n0 such that f of n less than or equal to c star g of n for where n greater than or equal to n0. Then next, omega notation. Omega notation is a method of representing the lower bound of an algorithm's execution time. Function of n, f of n is equal to omega g of n. If there exists positive constants c and n0 such that f of n greater than equal to c star g of n for all n where n greater than equal to n0. Then theta notation. Theta notation is a method of representing both the lower bound and the upper bound of an algorithm execution time. The function f of n is equal to theta of g of n. There exist positive constants c1 and c2 and n0 such that c1 star g of n less than or equal to f of n less than or equal to c2 star g of n for all n where n greater than or equal to n0. Then next one, speed up of an algorithm. The performance of a parallel algorithm is determined by calculating its speed up. Speed up is defined as the ratio of the worst case execution time of the fastest non-sequential algorithm for a particular problem to the worst case execution time of the parallel algorithm. This is the equation of the speed up. The speed up is equal to worst case execution time of the fastest non-sequential for a particular problem all divided by worst case execution time of the parallel algorithm. Then next, number of processors used. The number of processors used is an important factor in analyzing the efficiency of a parallel algorithm. The cost to buy, maintain and run computers are calculated. Larger the number of processors used by an algorithm to solve a problem, more costly becomes the obtained result. This is the second way of the uh, computer to improve the computation speed. Then the last method of the improve the computer speed of the computer is total cost. The total cost of parallel algorithm is the product of time complexity and the number of processors used in that particular algorithm. This is the equation. Total cost is equal to time complexity into number of processors used. Therefore, the efficiency of a parallel algorithm is efficiency calculate is equal to worst case execution time of sequential algorithm all divided by worst case execution time of the parallel algorithm. Then space complexity. When an algorithm is on a computer, it necessitates a certain amount of memory space. The amount of memory used by a program to execute it represented by its space complexity. Because a program requires memory to store input data and temporal value while running, the space complexity actually an input space. The space complexity is not given so much for importance. And then thank you.